Okay, cool. Um, so joining me is my co-founder Rachel, who's part of the webinar. And if anything goes wrong, she'll be messaging me, and then I'll try to fix things. But for now, I'll assume that all is well, and I will proceed. So for the next 1 hour, right, what will we be learning, right? So I'll be sharing my screen, and okay. So the agenda for today's webinar are two things. One is that Jackie will talk about data cleaning, followed by data exploration. Now, it'll be a mix of show and tell, and I will also be coding a bit, and you can see both data cleaning and data exploration in action. If you see me taking weird pauses in between, it's most likely because I'm not lagging. It's because I'm looking at my notes. So bear with me, right? Okay, so without further ado, you might be wondering who Jackie is. So a little bit about Jackie, right? I am the co-founder of UpLevel, right? So I guess I've done quite a few things in my time. It sounds like an old man, right? But okay, so I guess my background is less in computer science. It's actually I started off from biology, right? And I learned Python by myself. And eventually, my path to mastery was quite project based, which is also why okay. So someone fed back that I should put my slides on full screen. Fine, let's do that. Sorry, give me a second. Okay, so where was I? Right, my background is in biology, where and then I picked Python up. I think a lot of you in this audience today can empathize, where you started with one field and you decided to pick up Python and data science eventually. I started a deep tech insurance technology company a few years ago, and I sold it last year. Okay, oh dear. Um, give me a second. So I feedback that you guys can't hear me. Let me see. Okay, I hope the rest of you can hear me. Right. For my work, for my first startup, I'm in the Forbes 30 under list. I've spoken on TEDx before, and I'm very big on entrepreneurship. So I speak on that as well. Um, I then went to teach coding and data science, where I taught, I guess it's no longer close to 300, it's like over 300 students now. And eventually I started UpLevel, right? And that's where we provide project-based training. I'll tell you a bit more later, but so far with UpLevel, we've done over 20 plus data science projects, right? And our graduates have gone on to securing jobs, internships, even gone into the prestigious AI Singapore program. We've also supported the digital transformation for more than 10 companies. So it means implementing data science processes in any part of their company's journey. So, okay, if you're curious, I mean, just flashing this in case you're curious and you want to check it out later, projects.uplevel.work. I'll show the URL again at the end of it. I think some of you will receive emails from us anyways, right? And we are the company that have, we've trained students to do various cool things, right? To kind of like predict clinical trial outcomes using machine learning. For I think quite a few of you in the audience have indicated their interest in finance. We have trained students in using machine learning to predict blockchain price. That's kind of wild, right? Like, how do we do that? We've written a lot of it on our blog, and I hope you give our blog a look at some point. My personal favorite is Yishun, truly the most dangerous place in Singapore. We did that again using data, right? We looked into data, crime data, to see whether Yishun is truly the most dangerous. I hope there are no Yishunites among us, but don't worry, Yishun is actually not the most dangerous in Singapore. Check the blog to find out. You'll find your answers there. Okay, so question is, I'm here to share with you my knowledge on data cleaning and exploration. And yourself, I guess three profiles that might fit most into this talk, right? You might belong to one of these different groups. First is, of course, you've learned Python and you're interested in picking data science up. You're not too sure what's involved. Don't worry, I'll give kind of like an overview of what data science is all about. So you're interested in, in early data science process, right? You know more about data science, or you might have learned Python and you're not sure where to go next. This webinar might just be the thing for you. Now, a brief recap of who a data scientist is. Now, if you ask maybe 100 people what data science involves, you get 100 different replies. It's that fragmented. Nobody really has a monopoly on what the definition of a scientist is. Now, this is one of my favorite definition, right? Data scientist, someone who's better at statistics than any coders and better at coding than any statistician, right? So as data scientist, you're a curious blend of different skills and knowledge, right? And to sum it up in a Venn diagram, you must have both coding knowledge, statistical knowledge, and substantive expertise. Okay, this substantive expertise, right? Or I guess it's commonly known as domain knowledge, is actually one of the most crucial ingredients in successful data science projects. It's knowing the context. I'll talk a bit more about this later on. But the whole idea is that data scientists are generally multidisciplinary, right? They take different skills and blend them together and come up with amazing insights, right? So that's what you need: coding, statistical knowledge, and domain expertise. Of course, this webinar will provide a bit of each. Hopefully, we'll get to see it. So herein is a very useful overview of what data science involves. Of course, reality is what's happening in the world, right? It could be the collection of data in a company's server, right? So you collect the raw data and then you process the data. And after processing it, you have a clean data set. And that's when you do exploratory data analysis, or EDA for short. And once you've done the top half, you will go to the bottom half to, train models, um, apply algorithm, and then after that, you either make reports. Ooh, okay. Screen still has issue. Give me a second. So, okay, I hope the internet connection is well. You guys can see the screen, but let's see how it goes. So after that, you get a report, either that or data product. Now, what's a data product, right? A data product would be, say, a machine learning model. Okay, let me get out of this screen share and come back in. Okay, sorry guys, give me a second. I'm receiving feedback that there's a bit of problem with the screen share. I'm gonna stop sharing and reshare. Okay. Oh, present. Oh dear, something's wrong with the screen share. Okay, never mind then. Where was I? Sorry about the brief interruption. Seems to be a problem with the screen share, but it's okay. Right. So once you have a data product, which is kind of like a machine learning model that can help a business make predictions and whatnot, it goes back into reality where for example, for a good example would be if you go to, say, you buy stuff from Amazon or even Carousel, right? The recommendations that you receive, it's powered by all the different purchases in the past, and it's been uploaded in the server, and you get recommendations based on previous customers' purchases. Now, of course, once again, the focus of the webinar, we are going to talk about the top half, right? Highlighted in the red box, processing data, right? To get a clean data set, followed by exploratory data analysis. So at the end of this 1 hour that we're sharing, yeah, pace is still okay. You will learn and appreciate what data cleaning is all about, what it means to explore your data, and I hope you stick around so that you can see me typing on the screen and doing a bit of coding, and maybe wisdom that you probably won't get to hear from classes, right? Um, Usually when you go for coding classes, be it in school, in boot camps, or even short courses, like over a couple of days, a lot of it is focused on building a skill. So one of the things I hope to share in this webinar is also kind of like, okay, again, more feedback. Oh no. Okay, let me stop sharing again and share again. Okay. Okay, seems like it's all right. You know how is it in life? Everything goes well during tests until it's not. Yeah, shit. Okay. How about now? Give me a second. So someone chimed in that the issue could be due to graphics card switching, right? So truly unexpected stuff. How about now? So I feedback that my screen is frozen at who is Jackie Tan. So I'm sorry if you all had to stare at my face for the past 10 minutes, right? Damn. Okay, let me see. Okay, not frozen anymore. Okay, good. It's not frozen anymore. You know what? I think I'm just gonna not go full screen. I hope you guys can see it. So I was here earlier, and without further ado, let's go straight to the idea of data cleaning. So part one, I'm gonna talk about data cleaning. Now, believe it or not, right? 80% of a data scientist's time is actually spent on cleaning data. Um, Now, what does it mean by cleaning data, right? I'll show you examples of dirty data sets that require cleaning later on. But generally, okay, just as how I said, if you ask 100 people what data science is, you get 100 different answers. If you ask 100 data scientists what they spend on the most, all of them will tell you that they spend it on cleaning data. Um, Simply to look for patterns so that you can make sure that the data format is is it's correct, right? Or even if it's workable, you wouldn't want to work with say numerical data and halfway through you actually find text data that will throw errors. I'll show you what I mean later. So here's something, right? What data cleaning isn't, right? Now, why do we need to clean data? Um, Commonly, there are generally a few sources of data that you can get in the wild, right? So first, you have data that you get from scraping websites, all the way to calling APIs. So I'll show you an example of an API later on. So competition and public data sets are pretty clean. So if you go to places like Kaggle, hackathons, data science hackathons, the data sets provided are usually very clean. So that's fine. So is API. And if you work in a company data, sometimes because the data can be manually entered by people, you end up in a situation where you have human errors involved in the data set, which also means you need to inspect it and clean it if possible. And finally, scraping. Scraping is going to a website and kind of like grabbing all the data there, right? Sometimes it works if the website is structured. Sometimes it's not, but it's not, and that's when you get very dirty data, which is like when we want. I don't have examples of it because it's quite painful to clean, so let's not do that. But just trust me that scraping can lead to very dirty data sets. Now, let me show you an example of a clean data set. So this here is, uh, you might be wondering what's all these numbers, right? Now, I got this from a taxi API provided by data.gov. So you can actually, I don't know if you know about this, but you can get the GPS coordinates of all of the taxis in Singapore using this particular API, right? So that's pretty cool. Um, let me, oh wait, I hope you guys are still on the same screen. Okay, taxi. It's called the Taxi Availability API. It's called the Taxi Availability API. And this is the data.gov website. All these things over here are individual taxis. All these things are individual taxis that you can visualize in real time. And there's actually API for you to look at it. I mean, I encourage you to take a look at it when you have the time, right? So we can actually try it out. And when we execute, we get, these are all GPS coordinates of all the taxis in Singapore. Now, why do I say it's clean, right? I say it's clean because you get what you call for, meaning you get a very specific data set. I'll show you how we can turn this into a proper tabular format later on, all right? Now, this is clean because you have, what you see is what you get from the server. It's all good. Now, here's an example of a dirty data set. Why is it dirty, right? Is that let me highlight a few things. Okay. Now, okay, before I go there, this is a data set of presumably property information, right? You have the street number, the street name, and the number of bedrooms, right? And whether the property is occupied. So let's highlight a few things, right? First of all, for street number, you have empty places, right? Usually it's represented by an empty space, or sometimes if this data is manually entered by someone into a server, you may get NA sometimes. This is fine, right? You get street name, everything's fine. Number of bedrooms, you get three. Suddenly you get something like NA, right? This is problematic because if you try to process this column of data, you might end up having errors. 1, 3, NA, so on and so forth. Now that's even things like dash dash and then NA. Finally, whether the owner occupies this property, yes, no, no, 12, right? What does it mean to have 12? Again, you expect the shape, the format of the data to follow Y, N, and so on and so forth. But suddenly you get a number here, right? That's totally not right. We'll be looking at this again later on and see what I do to clean in our demo, right? So now I'm gonna switch over to another window where I have my Anaconda ready. No, my Jupyter notebook ready. So let me do a bit of sanity check. So I'm checking with Rachel whether the screen is okay. Rachel, how's the screen? Okay, never mind. Can you? Okay, good, all good. So what you have here is I guess, for the benefit of those who are not familiar with working with Python in other formats, right? This is what you call a Jupyter notebook. Now, Jupyter notebook is a very convenient tool for data scientists. The reason for that is because you get to write code in small chunks and you can execute it as is. So let's say if I just want to execute my import code chunk, then I will only execute this side, right? Everything else is quite modular. You can just type it in the code block and then execute, right? So what I'm gonna do is get the taxi data using the API. And I hope this looks familiar to you. Let me see. I hope this looks familiar to you, right? This is what we got when we called the taxi API. I've now called the API and brought the data over. So right now you see our pairs of coordinates, right? How do we access these coordinates? Now what you have here is this thing called JSON, right? JSON is a data format commonly used, right? It's quite a standardized format of data. Think of it as a dictionary. Think of it as a dictionary that you can use repeatedly. So this is your key, right? All your values, you go back in, maybe this is your key. These are all your values. So what do I mean by that? I'm going to declare a variable called cohort list where I will start off with data first, right? So this is what you saw earlier. Now, I am now going to go into features because this is where all my coordinates are kept in. So what I'm going to do is, whoa, getting closer to my coordinates, right? So now you can see from this square bracket over here, I hope you can see that there's a square bracket. We know that it's a list. So what I'm going to do is just get the first item of the list. Not much difference, except that right now we are looking directly at the dictionary. Key, value, key, value. Now you have the rest of this. We'll go into geometry. Okay, getting closer, getting warmer. And now we're only gonna go for coordinates. And finally, you have your list of all the coordinates at a given time, right? So again, the given time is actually over here. Year 2020, April 20th, 2 days ago, at 19 o'clock. 19 o'clock, oh, that's 7 p.m., right? So you can kind of guess when I started working on this notebook. I'm just kidding. Right, so are we able to collect all 24 hours of the taxi data on the 20th of April 2020? The answer is of course, yes, okay. Now this code block here, don't worry about it. What I'm doing is I'm gonna call the API for 24 hours. The reason why I'm doing this is to show you what a clean API would lead to, a clean data set. I'm gonna run this right now. So basically, earlier on, what you saw was this particular code chunk is to call 1 times worth of data. And if I do 0 to 24, you can kind of guess that I'm doing over 24 hours, right? 0 to 24. Give it some time for the code to call the API. Oh, there we go. We're done. So what you see here is a data frame containing 24 hours worth of taxi coordinates. So this is interesting. I mean, one of the reasons why I chose this was because we had a student project on predicting the number of taxis available in different locations in Singapore for one of the projects. So in project taxi prediction, we were predicting the locations of all the different free taxis around in Singapore over a time period. So that was quite an ambitious project because we caught like, I think, 1 year's worth of taxi data and tried to predict where they are. Of course, in this particular virus climate, the data we call may not be representative of reality because all the taxis are right now frozen, right? But that's a story for another time, right? So you see, it's clean because you have your timestamp over here and you just get your coordinates, right? What you see is what you get. It's pretty cool stuff. Now, I'm going to show you loading dirty data using what we saw earlier. So we'll start off with the housing data that I showed you. Right, I hope this looks familiar, right? This is just what we saw on the slides earlier on, right? So you have your street number, your street name. Now, sometimes when you parse your CSVs through Python, you might get a bit of change in the data form. We were looking for integers, whole numbers, but somehow after that it became float. That's okay. We look at number of bedroom, 3 nan, right? 1 3, and here you have a a string that's double dash and a string that says NA. We'll get to that later. Now, whether it's occupied, YYN12, okay, we've seen this. Now, let's start off with a few things, right? Let's say if I'm curious about the average number of bedrooms. Of course, this is all we have, but ideally in Python, what we do is housing square bracket num of bedrooms dot. Well, let's go with mean, okay? Mean is the average. Wow, what's going on? What's this huge um what's this huge chunk of error text, right? It says type error, right? Now what happened here is that um, a type error came up because not all of it are legit numbers, right? So, all right, what should we do with this? Let's take a step back. Let's take a step back and maybe first remove your null data, right? So what I'm gonna do is now, oh wait, no, sorry, drop NA. I'm just gonna drop NA, right? So when you drop NA, you're dropping all of the rows that contain a uh, uh, NA, right? NA means not available. Wow, okay. Now, I kept this short so we can see the difference between dropping NA and not. So this is one of the ways where people work with dirty data sets. They drop complete rows that do not have the information that they want. So in my case, let's say if I wanted to look at the average number of bedrooms in the housing data, I've removed NA, but okay, let's give this a try. Housing, well, let's just do drop NA, right? Equals to housing dot drop NA. And when I go like here, okay, so this is my new data frame, right? Bear with me, this is a quick and dirty way of doing it. So back to getting the mean of the rooms. Oh man, more errors. Why is that so? Again, we still have our double dash and our NA. Now, of course, we'll still have to remove these guys, but let's see what happens when we just tree. I hope you guys don't hear. Oh wait, sorry. Give me a second. I hope you guys don't hear something loud. Uh, there might be a bit of noise in the background. Let me just close the door. Can I tell you guys something funny? Of all times, right? My building decided to have. Okay, good, no noise. Okay, tell you guys something funny, right? Of all times in today, right? My building decided to have a fire alarm ringing right now. Ha 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 ha. You know what they say, right? Like, okay, never mind. So where was I? Right. Actually, number of bedrooms, right? Now, when I do mean, okay, let me just do the first three, right? 0, 1, 2, 3. Wait a minute. Why is it like this, right? Okay, someone asked whether this notebook will be shared. It's not exactly the most useful thing, but I guess we can, right? All right, thanks for the question, Gail. Okay, let's see what happens when we do this. wait, 03313. Okay, so 3313. But when you do the mean, what's going on? So what's going on here? Can you guys guess what's going on? Yeah, you can't, because we're supposed to get 3313. The average of 3 plus 3 plus 3 plus 1 is supposed to be 2.5, right? But here you have 828.25. That's because, yeah, let me just pick one, right? Do you see this? Do you see this thing over here? The apostrophe, where apostrophe is not meant to be there. That you have there is a string, right? So what we did is that we were averaging a string. Therein lies some of the intricacies of data cleaning. You cannot assume that the tree that you see over here in this column is actually a tree as in number, right? So we got a string. Of course, weird things happen when you try to perform mathematical functions on strings. Now, question is, what can we do, right? So a few things we can do. One is we do a type conversion. We force, yeah, let me to home in on the fact that we are working with a string. I'm just gonna do with, let's see, 0, right, string, right? But what you can do is something very simple. Ta-da, right? You use functions to convert your the different values here into a proper data format, into a proper data type, right? Once again, the reason why we were seeing weird things over here was because we were working with strings. Yeah. So I hope that surprised you, because it's meant to be. Many times when you work with a particular data set, right, you will be thrown off by things like this. It's part and parcel of working data, such is life. Okay, so next, let's go back to our housing data. Now, let's say if I wanted to know the proportion of own occupied over here, right? I want to see how many properties amongst the 9 that has an owner occupying it. Okay, it's easy here because we can just count it. But in a situation where you have thousands and thousands of rows, how do we know the proportion? So we now do own occupied, right? Now, there's one particular method that I enjoy using a lot. It's called value counts. Okay, value counts. It's wonderful because it'll tell you what are the proportion of different things over here. So right away, we can tell that there's a 5 yes, 2 no, and 1 12. Okay, so you know that one of your rows is weird, and you need to get rid of it. So there are a few ways to remove this. Let's see. Let's hope that. Okay, let's hope that this is not. Okay, where was I? Right. So from here, right, when you do value counts, you can then see how clean or how, I guess, contaminated your data is in this particular row. Of course, another way you can do it is manually inspecting. One of the ways you can do is do sample. So sampling is a very useful tool that I like to use as well. What was this? Okay. If you ever work with data frames, and usually people, when you learn in classes, right, they'll tell you to look at head, the first 5 rows, or the last 5 rows. But another useful thing that you can use is called sample, where you put in maybe just 3. I just want to do sampling. We'll do sampling again later on. just to show you the power of a good sample, right? So with this, we're kind of done. We see how dirty data can get. Next, let me show you guys a different data set. Okay, wait, not hit, just hit, right? First 5 rows. Let me get out of this notebook first and show you the CSV for this particular data set. So let me get out. Give me a quick 10 second. I'm gonna show you guys. I'm gonna show you guys the original data of it. Recent places, webinar. Okay, I'm pausing my scratch. I'm pausing my screen share right now. I'm looking for the original CSV. So, okay, stop share. Share screen. Okay. I'm gonna share my screen and I'm gonna share my screen again. Yeah, this time around is on. Now, believe it or not, right, one of the best ways to work with data initially is to check it out. Oh, oh, thanks. Thanks, Marcus, for taking screen caps of the notebook. Okay, so it seems like there's demand for the notebook. I will share it later on along. Okay, I'll just share the zip file for those of you who attended. I think I can get the attendees list, no problem. Now, what you're seeing here is a data set containing what you see here. Okay, I hope it's not a bit confusing, but this is actually a data set containing information on books, old books. You can see kind of old books, right? So date of publication. Date of publication is, wow, it's pretty old, right? Okay, they're all like very old books. But we'll be working with this particular column later on. So what I want you to observe is that you have a lot of potentially troublesome data set, because let's say if I wanted to do a distribution of the years that all these books were published in, you would immediately find that they're all very messed up, right? They're all very messed up. Messed up in the sense that where you expect only one particular year, you get multiple years, right? You get 1866, 76. That's not going to work if you're going to build a histogram of it. So that's going to be a troublesome affair. But that's part and parcel of working data, right? Okay, back to our notebook. Screen share. Okay, back to our demo. Back to this demo. Let me just hide my windows. Okay. Okay. When you read the CSV, you see that the empty ones, the empty places are gonna be replaced by NaN, right? That's useful because then we can kind of like see how empty all these different columns are. Now I like to use isNow.sum very often because it will tell you how many rows have missing, or rather how much data is missing in your data set. For example, let me just go with length here. Length of your dirty data set, 8,287, right? Immediately you can tell that in this particular data set, if you have 8,287 rows and there's 8,287 missing corporate author, you can more or less make an informed decision to remove this column altogether, right? And for example, things like former owner, you can remove it altogether, so on and so forth. Okay, well, I'm gonna speed through this a bit because it's 12:40 now. I don't want to take too much of your time, right? Okay, let me just show you. Value counts, if I do a value counts, you immediately see a few things. For example, 1897 is the most common year, right? But actually the more useful things that you can see at the bottom in terms of data cleaning is actually at the bottom, right? Where you have very um, rare dates of low frequency, and you can see that they're always in a particular format. Now, of course, you have 1148 of it. uh, it's, I guess you can export this and take a look manually, but what I like to impress upon you is that in data cleaning, sometimes all you need is maybe, okay, why am I showing you the last 50? Is because, right, let's say if the data set is dirty, right, usually sometimes they're dirty in very consistent ways. Over here, we can already see that you always have certain formats. 1844 to 79, right? You have a dash over here, you have a comma over here, and you have square brackets. Now, you have text like this, but I think again it's quite rare. So what do we do with this is that you can use maybe things like replace, okay? So replace is a very handy method where you can replace a character in a string with other characters. So the first character that I'm gonna replace is the front square bracket, and I'm gonna replace it with emptiness, right? So I'm just gonna try printing it every time I replace it. Okay, for contrast, let me just show you again what we should see in the first part. Yeah, so for contrast, 1879, right? This is the very first row. But once you replace and remove, let's say this guy over here, you see that, okay, I've removed one character over here. Of course, um, there are a few ways to replace your unwanted characters, but I'm just gonna do a very dinosaur version. It turns out you can chain these guys, right? You can chain, you can chain, you can chain them. Once I run, you see both brackets are gone, right? Uh, and then you go all the way to the bottom. You see that, okay, 1838, 1831, and you have removed things. Okay, so basically it's going through a list of characters that you want to remove and then iteratively removing them, right? Then you might be wondering, okay, how do I get each individual date? Of course, you can do things like split, right? Split, oops, split, right? So what split does is that it splits anything, a string, into a list based on a common character. Now, because I use dot split over here, right, you would get that the string that originally had an empty character in between to be split into two pieces. Of course, everything else is each, because there's no space, nothing is split and it remains as is. But what I can do is, of course, do a 0 and you get the first hits, right? Okay, anyways, data cleaning is in a way in itself fun because you're also you're working on a puzzle, right? You're working on a puzzle to make sure that all this data conforms to what you want. So just from this first step, you see that most of it is already single numbers. Of course, there are things like having a comma, having a dash, so on and so forth. Then you can do new things to split them. Okay, so that kind of concludes the quick and dirty version of what I teach about cleaning data, right? Okay, I'm gonna get out of this and go back to the slides. Okay, so now data exploration, it's not too, well, give me a second. Let me do a sanity check to see if the screen is still showing. Okay, cool, all good. Now, So usually exploration comes after cleaning because once you've you know cleaned the data properly and it's in a format that you can work with, next up is actually figuring it out. Now, one of the most important reasons why we do data exploration is really to find outliers or data that that do not conform or do not behave well. So here I have three different graphs, right? This thing here is called a box plot, um, and in a box plot you can sometimes see the outliers depending on which library you use, but usually outliers will be shown over here. Then you can see that okay, most of my values fall within 60 to 100, but there is someone at 30. Then you know, okay, this is messed up. Of course, you can also see things like outliers over here. Most of your points fall within that red line, but suddenly there's this guy over here. Last thing, you have a sine curve, or is it cosine? Yeah, you have a sine curve, and you can straight you can see, from the get-go when you graph it, that there's this stray point that's out of the guy over here. Now, on top of that, right, sometimes you need to do data exploration through visualization so that you can do a few transformation. Now, okay, I know this is a bit much, but typically we want our data to behave in a normal manner. You guys know a bell curve, right? Right, normal distribution. You guys have heard of bell curve. Ideally, we want all of our data to behave in a bell curve manner. Okay, I'm just gonna pick a random image and just paste it here. When you work with data sets, ideally your data should be normally distributed. It means you should have a proper mean and a small standard deviation. But if your data happens to be in such distributions, sometimes you can detect this kind of distributions of your data set through visualization, and you can take steps to fix it. I think for modern, most of the machine learning models out there, right, not having a normal distribution is okay generally. But if you're doing things like linear regression and whatnot, right, it's usually good to transform your data into something normal. So the data exploration step will help you detect the problem. Finally, right, another reason why we want to do proper data exploration is also to have an intuitive idea of what the data set involves. Now here, let me show you two examples of two data sets. Now let's say if I had two problems. One is to firstly predict the gender or sex of a particular person. Let's say if I'm training a machine learning model to predict whether a person is male or female based on his or her foot size, right? And here I have a data set that ends with it. This is the I guess the labels to be predicted. You have a 50-50 split. This is balanced, right? And chances are whatever predictions I make will fall within a proper distribution between male and female, 50-50 split. But in say in the realm of predicting things that are very rare, very infrequent, that's when things become a bit tricky. Because let's say if you work with an unbalanced data set, so let me just crop this so that we can focus on this particular data set. Let's say you're working with something that's pretty rare, right? Very common cases like fraud. I used to work on fraud before. I used to use machine learning with fraud. It's hard because most of your transaction, let's say if I had let's say if I had 100 rows, if I had 100 rows of data and 99 rows of it is actually legit, right? Legit transactions, and only one transaction is is fraudulent. Now, how am I going to split my data such that I can actually train my machine learning model to detect whether it's fraudulent or not. It's gonna be very hard. Now, in this particular example alone, let's say if the probability of a transaction being fraudulent is maybe 1%, you would expect 1 out of 100 transactions to be fraudulent. Okay, that's fine. But if I had a machine learning model that predicted all 100 transactions to be okay, once again, maybe I should write this down. Yeah, it's funny because let's say if I have 100 transactions, right? My ML model says 100 are okay, but one is fraudulent. What do you say about the, wow, I can't spell. Okay. So what can I say about the accuracy of this particular model? So 99 correct fraudulent cases. I say 100, oh wait, sorry, 100 cases, 99. I can I really say that my model is 99% accurate just because it said it was correct on the 99 non-fraudulent cases, right? Non-fraudulent cases. Okay, well, I can do many things. Spelling correctly is not one of them. Right, so food for thought. So in an unbalanced data set, you won't be able to detect this unless you do proper data exploration. So that's food for thought. Okay, demo 2. Okay, we're reaching the end. Hope. So here you have in demo 2, right? I'm just gonna show you the various things you can do with data exploration. Here you have the HDB data obtained from HDB, right? Public housing data. I ran this with one of my students back then. We were predicting based on all these different things, right? Like flat type, block, street name, story range, square foot. We were trying to predict the resale price. So we generated a few hypotheses and went for it. But in this context of our webinar, right, just want to show you what we can do with in terms of data exploration, what it means to do data exploration. Now, just now I said we want to look at the normal distribution, whether a particle column is normally distributed. We do that by using a histogram. So V bracket. All right, let's do floor square meter. Boom. Okay. Now we can kind of tell that most of our square footage in our data set belongs to between 110 to 100, no, 100 to 110, right? It's not exactly normally distributed, but we kind of can see that it's okay, right? Um, that's one thing. So you can start thinking, okay, it's not so bad. And let's say we want to see resale price as well, the resale price, the distribution of the resale price. Wow. Okay. Again, I would say this is more or less like this kind of like a right skew, right? Let's go back to the, okay, never mind. So take it from me, right skew, it's not exactly in the center, right? It's not exactly in the center. It's because you have a long tail. We call this a long tail, right? Most of your values are around 400K Sing dollars, plus minus 200. But you have a bit of rare cases where it goes beyond $600,000. So this is how you kind of like build intuition around your data set. Let's see. Now, how about for text data? There are various ways to do it, but for let's say town, right? Something that's categorical. We are looking at town data. What you can do is use bar plot, right? Bar HDB. Okay, I hope this works. Shouldn't work because it's only text information. You need to get the frequency of your text. So what you can do is, okay, give me a second. Okay, I want to do instead, I'm going to do a value count. Remember I talked about how useful value count is. So I'm just going to show you what you see when you do a value count of your column data, okay? Ta-da, okay, you see, sorry, value counts. There you go, right? From this, you can summarize. You can kind of like summarize what the frequency of the different places in your data set is. Most of it is in Jurong West, Sengkang, so on and so forth. Now, of course, from there, you can actually build a bar plot around it. Yeah, wow, looks ugly as hell. But you get the idea, right? SNS.bar. Let's see if I can make it prettier. It does look pretty. Now it's in rainbow color. Of course, the other things you can do with it. Let's see. Okay, it's bigger. Of course, the ticks are still messed up. Let's do a quick fix. Yeah, okay. Now it looks a bit better. Of course, this is great if you're gonna show it to say your boss, right? Oh, look, boss, rainbow colored bar plot. But it does look kind of nice. So from text data, you have um, done a quick summary, right? Be it using value counts or whatever you like to do, and presented in such. It's so much easier to consume. You can tell, you can with one glance tell your audience, whoever it is, that hey, ta-da. Now with this, you can then do it with other things like flat model. Let's do a quick flat model. Yeah, boy. All right. See, most of it is model A, improved next generation, so on and so forth. Now, does data exploration is it limited to just examining one column data? Of course not. One of the things we can do is also examine correlation as well, right? So what we have here is remaining lease. So remaining lease means how many years left on the property, right, before the government takes it back. Ha, ha, ha. Now, fortunately, we also see an example of dirty data set. This lease has been pre-processed. I actually took this from my student's project, right? What he did was he went through the remaining lease column. He multiplied it by 12 to get the number of months left on your lease. But hey, how about this? You get 67 years and 03 months. Now this is actually a string, right? You can't immediately convert it to a number. So what he did, he stripped years off, he stripped months off, and combined the two to get what you have. So what happened if we tried to say do a histogram on remaining lease? Okay, you know the answer. We will get into an error, right? But I'll still like to do it regardless. Hist, right? So that's why we cannot take our data for granted, because let's say if we did a dot hit, right? We just did a dot hit without proper examination of the data. You think that our remaining list is okay, right? And then you'll be in for root shock when you realize, alamak, you know. Okay, wow, okay, this is bad. Well, it's taking forever to process because it's encountered strings in your data. And when for this particular method, when you build a histogram with strings in it, it's gonna take forever. So what I'm gonna do is I'm just gonna interrupt this guy. Okay, let's not do that. Instead, let's do these. Okay, something's wrong. No, let me just interrupt this. Come on. Oh, kernel appears to have died. It will restart automatically. Yep. Okay. Let's just go through this again. 1, 2. Oh, okay. It's 1 o'clock soon. Sorry about that, guys. I got too carried away. There we go. Right. So you can see that the lease come in 2 different durations. One is most of it, it's 800 months. not so much. So this is pretty cool, right? Of course, if I wanted to do bin, I want to bin it smaller. If I don't want to see gaps in between my bars and histogram, um, is this now normally distributed? The answer is generally yes, because it's kind of like bell curve like, but right, of course, if you start going to something more granular, then it's no longer normal. It's actually bimodal. You have two different peaks over here. 1, 2, 3. Weird. Okay. Last part of this EDA, right, exploratory data analysis, is to actually um, now the reason why we are data scientists is because of the word scientist, right? We come up with hypotheses and then we test the hypothesis to get some kind of to see if our data supports our hypothesis. Now, all of you, you guys stay in property and whatnot, right? So you all have an idea of what's correlated with property price. That's good because you're using intuition and educated guesswork, and in a way, domain expertise as well, to try to see what's the correlation between your resale price and something. Now, I have here a scatter plot. Okay, let's say I'm this naive guy who doesn't know what's correlated. I'm gonna start off with lease. Okay, let me see if lease remaining on the property is correlated with its resale price. Ha! Doesn't look like it, does it? Right. Of course, I can try a few more. Right. Whether it's a flat model, whether it's a flat two type. Okay, this I'll probably cover this in a future webinar. Right, like how to work with this data, like text turning from text data into numerical ones. But of course, the most obvious answer is actually floor area square meter. Now you might be analyzing this data and you have a hypothesis. Okay, it might be floor area square meter. Okay, I'm cheating a bit, right? Because I know this data. But after a while, you'll be like, wow, okay, look, it's much better than the previous one, right? You can definitely see some kind of correlation between the total square footage of your property and the eventual price of it. Of course, it's not perfect because while you see an upwards trend, it's not exactly very clear. This is where things like machine modeling comes in, or multiple linear regression, so on and so forth, comes in to use the rest of all this data set to improve the model. So yeah, so that's a quick, I guess, quick introduction into what data exploration is all about. Firstly, to look at your individual columnar data, right? And also to look at maybe correlations between two different kinds of data. Okay, let's do one more thing. I don't know if I have time for it. Okay, sns.boxplot. Okay, I'm gonna do a box plot instead. Okay, what? Let's see if we can do this. All right. I'm gonna change this to something interesting like flat type, right? Flat type. Okay, here you have. Okay, maybe I should make it bigger. Yeah, boy. Right, check it out. So, again, intuition kind of helps us with interpreting this data set. One room flats definitely cheapest, and you can see the amount of the price of the property increases as you have more and more rooms. Okay, so okay, this is kind of a spoiler. I don't have time to do this now, but usually you want to see a nice linear progression from bottom to top. So yeah, so this is what EDA is all about. And then after this, once you've done the exploration, you can then proceed to machine learning modeling, but that's for another time, right? Okay, so, okay, I didn't cover this much, so I'm just gonna delete it. So these two particular methods are very useful when you work with data sets, right? You wanna see the value counts, you wanna see if there are any low frequency outliers. It's now.sum to see whether how complete your data set is. And I guess a few other things. Visualization is important as well. So with 6 minutes overrun, thanks for being with me, everyone. Well, before I end this this webinar, right, a few tips and tricks. So when cleaning data, right, make sure you check if you work with data in a CSV form, it's good to look at the raw data directly. Don't just jump straight in your notebook and analyze the data. You gotta look at the what's this? Someone sent me something. Um, you gotta look at the data directly, right? And dirty data comes in all forms, be it, you've seen two examples, right? One is the data is missing. Another one is that it's actually a string instead of integer. So that kind of messes things up. Exploring data, we didn't, okay, I didn't get to do this, right, be thorough. But it's also important to understand the business problem properly. Now, if you were looking at a housing data pricing, right? It'd be good to have intimate knowledge with the housing scene, right, in Singapore, so that you have a better idea of your data set. So I guess this thanks for being with me for this hour, right? Before I end proper, well, this is kind of like a taster of what you do in a particular project. And if you'd like to know more about UpLevel, please, oh, okay, that was a faux pas. To learn more about UpLevel, please head on here to our URL. You can visit our URL. We'll be sending you all a follow-up email after this webinar. I'll be holding more webinars in the future. I hope you can join us. If there's demand, we'll most likely have one more on something later on in the data science process, right? Because today I've only spoken about cleaning and EDA. Next up is actually modeling and well, maybe turning your product, maybe turning your data product into something that's deployable. Let's see, who knows. But yes, if you like, I guess, project-based training, please check us out. We have a webinar special on top of COVID special, right? Everyone's learning from home now. You're gonna be wondering what to do with all the time. Why not spend your time with us? We typically take students who have learned Python already and are looking to up level themselves to the next level, right, with projects. We have beginner projects, we have intermediate projects, and we have very advanced projects as well. So we have students who start off from something simple. I have a student, okay, so I have a student who went through 3 different projects with me, right? And after going through 3 projects, he actually built his own computer to do deep learning. And he said, Jackie, thanks for everything. I now can fly. I'm like, wow, okay, pretty cool. But yes, please drop, well, I guess you can drop me a Telegram over here. You can drop me an email as well. You can reply, well, you can reply or send me an email over at Jackie at uplevel.work, right? So now you get my details anyways at some point. But yeah, so we have a promo right now. If you sign up, you might even get more promo. I don't know. So that's the end of our. Oh yeah, one more thing. Sorry. I'm a very long-winded man. Okay, so just want to show you what's over at our URL, right? So this is our website. You can read up on our past projects. So earlier on, this is so the data set came from this particular project that I did with 2 amazing students. We call them data knots. I know a few of you are interested in the finance industry, but give other domains a try. So this is blockchain. We were trying to predict blockchain pricing using the white paper. We looked at PSI data. This is Project Yishun, which I mentioned. This is a project done by It's a cool project done by a student of mine. He trained a model such that given a list of ingredients, he'd be able to predict what cuisine it'd be, right? So if I say raw fish and rice, you think of sushi. That's what his model can say, right? And then we've also looked at this, okay. If anything, right, I'd like y'all to give this blog post a look, because this is one project that I did with a student. And what we did was that we analyzed data scientists and analysts LinkedIn profiles, right? And we extracted the, oh wait, sorry, we extracted quite a few important information, such as what are the key languages you should know to be a data scientist, which platform to go to, what are the skill sets, like do analysts and scientists have different skill sets? The answer is yes, right? And you can see all this. So we did a breakdown on the educational background of scientists and analysts and what you need to do to, move from one place to another. So cool stuff. If anything, check out our blog posts for inspiration. Yeah. Um, Once again, thank you all for taking the time to to listen to me share a bit about cleaning and exploration, and I hope to see you guys again at some time. A big shout out to those who messaged me to let me know of errors in between, and thank you all for your patience. This was my first webinar. It's quite an interesting experience, and I think I look forward to doing more of it in the near future. So keep an eye out in your email. Hopefully, our emails don't end up in spam, right? I hope. Okay, and on that note, thank you everyone. Have a good day ahead. Have a good week ahead. Stay safe. Yeah, stay safe. Hydrate yourselves, and don't go to crowded places. All right, everyone. Thank you so much. Bye bye. Oh, okay. Well, if you guys are still here, I can show you my cat. Cha. Hope you guys like cats. Yeah, been around disturbing my papa. This guy's terrible. Look at that. Ah, oh shit. Okay. Well, bye bye everyone. Oh man, this guy knows the real webinar. Oh man. Huh? Huh? Okay, never mind. Okay, I'm gonna end the call now. All right, bye guys. Oh. So Cha is this furry guy who keeps me up at night. Bastard. Okay. Okay, end call. I'm gonna end this call. So well, goodbye everyone.